So this video is a follow-up to the Pythagorean Theorem and talks about the converse of the Pythagorean Theorem and two resulting inequalities that make some statements about triangles based on the Pythagorean Theorem. So as a quick review, remember the Pythagorean Theorem deals with right triangles and says that if you square the length, if your triangle is a right triangle and you square the length of the hypotenuse, then that is the same as the sum of the squares of the lengths of the two legs. And if we were going to talk about this in if-then terminology, then the if would be if we have a right triangle, and the then would be the relationship between the hypotenuse and the two legs. Now, normally we refer to this in shorthand using the a squared plus b squared equals c squared formula. The formula itself is not the theorem, it's just the one that describes the theorem. Well, if we take the converse of this theorem, meaning that we take our if and our then and we switch the order. Here it's if it's a right triangle, then this relationship exists. We get if the square of the length of one side of the triangle is the sum of the squares of the lengths of the other two sides of the triangle, then it's a right triangle. And so basically what we're saying is if we have a triangle and this relationship is true, then the triangle must be right. Now, not every theorem is going to be able to flip like that and still be true, but the Pythagorean theorem is, and we'll talk about the reasons why it is true and a proof of it a little bit later, not in this video. And so, apart from it being interesting that the Pythagorean theorem is something that follows this idea, which is that we can start with the right triangle and get the right formula, or we can start with the formula and get the right triangle, it's interesting to think about what happens if the formula doesn't work. Like, for example, what happens if we take a squared plus b squared and it's less than c squared? Well, if we think about it as here's what a right triangle would be if it were a squared plus b squared equals c squared. And if a squared plus b squared equals c squared, this is what it would look like. But if it's less than c squared, that means that c is too big for this right triangle. And so rather than it being that long, maybe it looks like that. Well, in that case, in order to make the two side lengths fit, we can't have a right angle. Instead, we are going to end up with something that looks like this, where the two side lengths are the same, but we sort of have to condense this angle down here and make this angle larger so that it can reach a little bit farther along to hit the end of what would be the hypotenuse. In that case, we end up with an obtuse triangle. So if c squared is greater than a squared plus b squared, then the triangle is obtuse. So go ahead, write this down, pause the video, saying that a squared plus b squared is less than c squared. That means the triangle is obtuse. All right, and before we move on to the next version of the inequality, which is basically the reverse, we're going to go back to the last page. Go ahead, pause the video, and write down the converse of the Pythagorean theorem too. If the square of the length of one side of a triangle is the sum of the squares of the lengths of the other two sides, then the triangle is right. Pause the video, copy that down, and come back when you're ready to move on to that next inequality. So we already talked about what it means if a squared and b squared aren't quite big enough to make it to c squared, or if c squared is larger than that, in which case we end up with an obtuse triangle. But what if a squared and b squared end up being, or a squared and b squared, end up being bigger than c squared? In this case, c isn't quite big enough to make the right triangle, so if we started thinking it was a right triangle, c would end up about there. In which case, the angles would also shift slightly, but rather than the angle having to widen to be able to reach farther, we may end up with a case that looks like this, where this angle actually gets smaller, so the side rotates in, and this angle gets bigger. But in this case, if the longest side is not long enough to make it to become the hypotenuse of a right triangle, then the angle that would be the right angle becomes acute. And so go ahead, copy this relationship down. If a squared plus b squared is greater than c squared, then we have an acute triangle. And so using those three relationships that we know that a squared plus b squared equals c squared is a right triangle. A squared plus b squared being less than c squared gives us an obtuse triangle, and a squared plus b squared being greater than c squared gives us an acute triangle. We can go ahead and just, knowing three side lengths of a triangle without knowing its anything specific about its angles, calculate and determine the type of triangle it is just by seeing how these formulas fit. Remembering that C is always the longest of the side lengths, even if this diagram here doesn't make it look like that. So for each of the following problems, you're going to use the Pythagorean formula to determine the type of triangle, acute, obtuse, or right. Plugging the values into the formula and then just determining what type of triangle is this. So 2 problems per page. Go ahead and pause the video, plug these into the formula, and see what type of triangle we get. So for the first one, 6 squared plus 8 squared and 10 squared, 6 squared is 36, 8 squared is 64, 10 squared is 100. 36 plus 64 is actually equal to 100, so this is a right triangle. For 4, 6, and 8, 4 squared is 16, 6 squared is 36, and 8 squared is 64. Well, 16 plus 36 gives us 52, and 52 is less than 64. Since 64, this gets to a squared plus b squared is less than c squared, this is an obtuse triangle. All right, 2 more problems. Go ahead, pause the video, work out these 2, and come back when you're ready to see the answers and move on. So again, we have a squared and b squared. A squared for 3, 4, 6 is 9. B squared is 16. And c squared, because c is always the largest, is 36. Well, 9 plus 16 is 25, and 25 is less than 36. So this is also an obtuse triangle, because the hypotenuse, quote unquote, is too long for it to be a right triangle. For the next one, 8, 10, and 12, a squared equals 64, b squared equals 100, and c squared equals 144. In this case, a squared plus b squared is 164, which is greater than 144. So the side that would be the hypotenuse isn't quite long enough to make it all the way to the edge of the leg if we were to try to set it up as a right triangle. So this is acute. 1 more page. Go ahead, pause the video, calculate what types of triangles these are, and then come back when you're ready to see the answers and finish up with the video. So in the first one, we have root 7 squared, which is 7, root 7 squared, which is 7, and root 14 squared, which is 14. And if we add a squared and b squared, which can be the same, we get 14 because it's 7 plus 7, which is equal to 14, so this is a right triangle. And in the last one here, we have 4 squared equals 16, 4 root 3 squared, which is 4 squared times root 3 squared, which is 16 times 3, so this is 16 and 48. And then 8 squared, which is 64. Now, if we add 16 and 48 together, we do get 64, so this is also a right triangle. And so for this, for the knowing the 3 side lengths of a triangle, the Pythagorean theorem and the Pythagorean formula is actually far more powerful than just verifying that it's a right triangle. We can tell whether it's an acute or an obtuse triangle too, based on how the sum of a squared and b squared relates to c squared.